everything. Let's get busy. There's no time to be getting busy here. No, all right. Okay. So, how about it? Let me put on my so-called background. I thought my phone was here, but I'm gonna have to look for it. All right, let me take a look. Where is it? Where is it? Okay. Okay, that's better. All right, let's see here. Is there music to be heard? Yeah, I think that's fine. Okay. Okay, so we did this awk. Okay, let's try and do like 6 here in the middle of the day, and I'll come back in the later afternoon and do like 6 more. That's the goal. So the idea here is going to be, let's just find some easy ones. Like, are there any leaps yet left that I haven't finished? Yeah, here's one in LFE. Oh, it's the weekly check-in again already. I don't feel like I'm prepared to try it in UA. Anything with a resistor is very simple, I believe. We see resistor a few places. Oh, Zig, resistor color duo Zig. That should be an easy one. I think. We'll see, we'll see. All right, let's go to Zig. Okay, so then we have on my list uh, when did I resize that? Okay. Resistor. Was it color duo? Yeah, resistor color duo Zig. All right. And I have done this one before, right? No, actually not. Huh. I have it here in TypeScript. Did I not finish it in TypeScript? Let's do it in Zig first, and then I'll look. Okay. So we expect color band 2 times to be passed in. Do we need to implement the color band? What's in here? Resistor color duo dot color band. So the colors, it should be 2 of color band. And I think color band is something like a union type that's just strings, I think. Okay, so let's look here again. Oh no, no. It's more like an enum, right? Brown, black, blue, gray, yellow, violet. Okay. Okay, so let's just look for a quick hint. Zig enum. I hate the way it auto-completes. Okay, so okay, yeah, that looks good to me. So we'll say const, and then we'll say the name, and then we'll say it's an enum, I guess. So I'll say const color band equals enum, and we'll put these names that they had, right? So they had red, blue, orange, brown, black, white, silver. There should be 10 in total, right? Green. Oh, I think it's gray here. Okay, and then violet is one. But we need to make sure they're actually in order. Okay, here we go. So it's black, brown, red, orange, yellow, green, blue. In school, we had to learn these. Violet, gray, white. Okay, so does that look like our enum? Okay, then we say compile error. So we're supposed to pass back a usize, so unsigned. All right, so I guess they threw that in there just so that the compiler would let it compile without saying, oh, hey, you didn't use that. All right, so so does it say anything about turning an enum like back into a number? Int from enum? Int from enum. You can override the ordinal value, but we don't need to do that. So we're just gonna say return. Why does it say recording? I don't remember what's recording. I think it's is it maybe Q or no, it's not Q. Um It is Q. Yeah, I haven't used it. I haven't learned to use it, so whatever. Okay, so we will return at int from enum colors sub-0 times 10 plus at int from enum colors sub-1, right? So we think that's about it. Let's see what it says if we... Oh, what does the help say? Here, we can close this, I guess. Zig test. Okay. Zig test test. Let's see what kind of result pops out here. Okay, so it says color band is not marked pub. That's a good hint. Okay, so we ran the test. It said panic integer overflow. Huh. Panic integer overflow. At int from enum. Pass that in. It should be... All right, so what is the answer now? I don't know, man. It's telling us what the problem is, right? So we went in here and we tried to do times, I guess, and it said panic integer overflow. So I guess something must not have been as I expected. Let's go somewhere else. So this is Zig, and we are going to look at integers, right? That's what it says. Integer overflow. Okay, let's take a look. Have no size limitation. Values a and b are known only at runtime, and thus this division operation is vulnerable to both integer overflow and division by 0. Okay, so we got integer overflow. That's pretty messed up. Okay, so we did a multiplication, which apparently caused integer overflow. U8 and added 1, and then it was like, so, nope, sorry. Okay, so I think we have to look at what integer type came back when we did int from enum, right? Integer tag type. Okay, so... Alright, real quick. Let's go back up to integer, and I think we can do casting or whatever, right? Wrapping operations? No. Oh, okay, let's do this. So we'll say first u32 equals int from enum colors sub 0. We'll call it const. And this will be const, and we'll call it second. And then here, we'll just say return first times 10 plus second. Okay, so it says 6 tests passed. Is that everything that was in there? So we avoided the integer overflow, because, I don't know, I guess it just gave us a very small integer to work with. I don't know, just like a 4-bit integer? Is that what it gave us to work with? Interesting. Okay, so let's look at the tests. So I've got 1, 2, 3, 4, 5, 6. Okay, yep, that's it. Okay, now zig. Zig format. Zig format. Yep, it is a small one, just like I said. It was like integer overflow, right? I guess they gave us like, what, a 4-bit probably integer. That's crazy. All right. Yeah, let's test and submit. I got monster. Check it out. Yeah. This is the middle-aged man degen life right here. Okay. All right. So that's cool. So I'll mark that in my sheet. Scooch that guy over. Cool. All right, let's look at some of the other resistor ones, because, I mean, they are quick, and I just want to knock some out quick today. This one is pure script. No, it's pirate. Okay, yeah, let's do it in pirate. Resistor color trio pirate. I wish that it was that, like, through the UI they made it easier to find an exercise on here, right? Like, it does look like a nice UI, but I feel like in addition there should be something to help us find the actual exercises without necessarily having to go into here. So this one's resistor color, but it said trio, right? So let's hop into that one, I guess. All right, so it's an R file because we are pirates around here. I also have beans. Gonna Gonna, you know, munch them out of the can. Just eat them right out of the can like a cowboy. Like a cowboy or a bum or something. I don't know. All right. Find my spoon. Take a bite of my beans. All right, one sec. They call them, the label says chili mild beans. The ones I used to get, they said chili hot beans. And I don't think they taste any different. I think they just changed the label for some reason. Maybe they do taste different. Maybe they do taste milder. I'm not sure. Like when they were called chili hot beans, they didn't really taste hot. But I've never like on the shelf at the store they used to have just chili hot beans. There wasn't chili mild beans. And now it's just chili mild beans and they don't have chili hot beans. Maybe I'm crazy. Maybe I need to go to a different store. All right. So anyway, I think this is a simple one again. So this time I guess it's 3 of them. Okay, so we did the first 2 colors. So this is good. So let me just see. If we look at the test, looks like they just get passed in as strings. Easy peasy. And we pass our answer back as a string. Okay, so if it's over 1,000, we're going to put kilo. And I guess we're probably going to put mega somewhere here. Yeah, mega right here. And giga right here. Maximum possible value. Right. Okay, so that's almost like a spoiler, but whatever. Did they show a decimal number in those tests? $650, 8, 99, 0, 67, 470, 51, 2. So not showing any decimal numbers, I guess. Huh. Interesting. Because, like, what if you were to do red, red, red? Shouldn't that be 2.2 kilo ohms? Diminishing Shankler F. Best viewers. Incredible. Regardless of mild or hot, it's a very tasty beans recipe. Alright, so anyway. Yeah, that actually seems lame. So, like, hold on. So, if we had, let's see. So here we have blue, green, yellow. We don't need to worry about orange. It just says ignore it. Okay, so blue, green, yellow comes out 650. So what if it were blue, green, red? Shouldn't that be 6.5 kilo ohms? I would think so, but it doesn't have a test for that. I wonder why not. Oh, and are any of these, like, skipped? I don't think they have them skipped, so that's good. Marksman? Oh, sure. Me typing very slowly. Alright. Okay. So, let's do a fun digit from color. So we'll do colors equals black, right? And brown, red, orange, yellow, green, blue, violet, gray, white, right? Seems fine. So then I guess we're going to do find. Let's take a look at pirate. Pirate, sure, right there. Pirates list are of the head and tail variety found in many functional languages. Hmm. List. So, truth be told, I guess I actually want to do it as a case statement. So this one says cases. Why is it list in here? Cases list one? So this is, oh. So we put a type annotation in there, right? They did list in every case here. But I think it should be string for us because we're working with a string, right? That would make sense. So I'm going to say cases, string, and then color. And then we're going to say now here, do we need this? Yeah, right? Okay. And then we don't have a comma, we have a fat arrow. Right? Yeah. Oh. All right, so in any case, that's basically it. Then we don't use this. And actually, I think that's the whole function there for digit. Now, with pirate, do we have a REPL? Oh, we don't. Or do we? Do I have something weird going on? Hmm. There is something weird going on. Pirate, help into bat? Huh. It doesn't normally do that. What is happening there? Interesting. Okay, so Perilous? It doesn't look like REPL is an option, so that's unfortunate. There's something odd about the help. Okay, so don't delete this line when using Pirate on Exorcism. Okay, sure. Provide label end. Not too sure what that's for, but okay. Looks like it's referring back to this, right? So that must be saying that we're going to export it, basically. Let me see if my AI can speak to us. AI, why does pirate say R and not jar? Okay, so yeah, basically. It says pirate old language R equals array. What the? Where did it come up with that? That's crazy. It comes up with crazy things. That's why I keep chatting to it now and then. Because I find these crazy things that it comes up with kind of fun or something. Alright, so number, color. So here we return digit. Oh, this should be colors. Oh, wait a minute. I think I need an end here. Or something. No, shoot. Okay, so when we do it, we're supposed to put end on the cases. And then I think we're supposed to put end on the, like the function as well, probably. Okay, so this is end. So we have cases, and then we end. Wait a minute. Do we also need a default case? We need an else. Else. No. How did? Okay, yeah. Else. So we're gonna put digit colors sub 0 times 10 plus digit colors sub 1. Well, I'll see how well this works, if at all. And then we'll say raised to the power of colors sub, or excuse me, digit colors sub 2. So now we're supposed to go pirate Okay, so it says, is there a missing colon, comma, string marker, or keyword? Oh, you know what? Strings probably have to be marked with double quotes, it sounds like. That's probably not the only problem. Let's see. No, it says the same thing. Is there a missing colon, comma, string marker, or keyword? Okay, so again, cases. Okay, it seems okay so far, I think. Um, so provide label end, fun digit color, cases, string color. I feel like I must have missed something obvious. Cases, animal, a, colon. Wait a minute. Cases, list L, empty, shoot. Hmm. I think I did something really dumb. Right, branches that split computation along the boundaries defined by your data definition. Okay, so this is the top level. Language concepts. Okay. Cases expressions. So I think I need to change it to if. Fair enough, fair enough. You might be able to do it with cases, but not like this. So, yeah, it's gonna have to be if, I guess. If color equals. If color equals. Hold on. Does this not work the way I thought it did? Shift, motion, no. Not. Did we find okay, so not this. Pirate programming language command line format auto. Okay, these are all about Python, so I don't think we had such a thing. Indent your code block using 2 spaces, not tabs. Okay. Well, if they're not going to provide an auto formatter, I'm not going to worry about it much. So now let's look at the if-else again. So it was, let's see, expressions. And where's if, tuple expression. I'm spending way too much time on this. And it's pure skill issues. Okay, so we want else if. Right? Okay. Alright, is this better? I think it's better, but we're not there yet. The name label is unbound. It is used but not previously defined. Oh. There is an empty block at 35. Okay, okay. Cool. Let's go to 35. Ah, right here. Okay, great. So for now, we're just gonna say number colors and see how far that gets us. It's not gonna finish anything because we need to format it as string first. But let's just see if it runs. Okay, label, and then it says cannot be mixed but star. Okay, operators of different kinds. Oh, yes. I sort of do remember that. Okay, so yeah, we mixed those. Okay, so it actually ran 1, I think, and it says failed because got unexpected exception. Okay, so we tried to use a bracket expression, but it was a list that was passed in. Okay, okay. So we did a list. Okay, so I believe what we can do is say C, hold on. C1, no, shoot. So when we want to get all of them, look again if there's a hint. Return the nth element. Yeah, sure, let's do that. So for that, of course, we could also use first, but let me just use get for all three, I think. Unexpected exception, and it says the left side was not, it's on 33. I think I just mistyped something. Resistor color trio 33. So what's that supposed to match? Here? Yeah. Oh, it still says the same thing. The left side was not a function value. 33. So we're gonna say D1, yeah, so D1 equals digit colors get 0. D2 equals digit colors get 1. Exp equals digit colors get 2. D1 times, wait a minute. So D1 times 10 plus D2, right? And then what about operators? I don't see the one I was hoping for. Darn. Exponent, exponent, exponent. Where would it be? Right here. No, that's not it. First raised to the second. Num exp t. Okay, let's use that. Num exp t. Okay, so then we'll pass in this. So far, so good. And exp here. Right? On 35, it didn't understand. Next token is comma. Okay, cool. So finally got there. How much time did I just spend on this one? The first one was relatively quick in Zig. Not so much here. Okay, so now we're just going to turn it into a string. I guess it's not there. Okay, so let's look at built-ins, strings. We basically just want to be able to, I guess, concat or something. String append. We can do string to number. And then can this one go to string? Num to string. Yeah, num to string. Okay, okay. So we're going to do a string append. String append. And then this is going to be number to string. Okay, I think that, finally, after all this time, might be enough to make the first one pass. No, not yet. Not yet. Number to string. Oh, it's just num to string, excuse me. Let's see. So values not equal 1 ohms, 33 ohms. Okay. So what did they equal? What did they equal? Orange and black. Right. So that should be. Oh, 1 ohms is what I got back. Okay, okay, okay. All right, all right. We're getting there, I think. So orange. So here's orange. So it was supposed to be 3. Goodness gracious. I'm starting to think the only FP type language that I like might be Erlang. Erlang seems nice. The rest of the, and to be honest, maybe if I tried messing with Erlang more, maybe I wouldn't like that either. Okay, so yeah, I mean, if you're gonna do serious work here, you gotta read the whole manual. It's always like that. Oh, do we have pirate here? Not a big surprise. Um, okay, so now we're gonna try print D1, right? Contains a block that contains multiple expressions, 31. Mm. So we did print. So let's see. If you are writing code to purely cause side effects, write a when instead. Boolean. Yeah, okay. Contains a block that contains multiple expressions. Either simplify this block to a single expression or mark the outer expression with block to indicate this is deliberate. so we said... So if we get rid of these, then I guess it's fine? Or no? Well, let's see what it says. Okay. Come on, let me print something. Please, 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 let me print something, please. What does it say about print? Okay, so print, 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 okay. I run into these things and then I slow down. It's psychological, really. Right here. Okay. It displays the provided value after first calling toRepr on it, then returns the value. So if I put print result here, okay, 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 we can do this. So we just want to wrap everything in print, basically. Okay, well, I don't see anything printed, so that's lame. Hmm. Okay. Let's slow down. Let's just look it over and see if I can discover why it's coming out as 1 and not 33. Man. Hmm. So why did I not see anything printed? Oh wait, here it is. Here it is printed. 3301. Oh, okay. Well, that's right. That's what it was supposed to be. Okay. I didn't realize it was all going to be printed on one line. Hmm. All right. Fair enough, I guess. 3301. Yeah, that's what was well, the 330 is right, but what's the 1 about? Okay. Finally narrowing it down. So 330. Oh, wait. Was it black? Yeah, that would explain it. Man. Okay, orange, orange, black. Let's look at the README again. So black is 0. Interesting. Um, oh my gosh, again. So yeah, like, this doesn't make any sense. Like, whatever I did here is complete nonsense. So, multiplier equals... this is the thing, I've said this many times too. I make these boneheaded mistakes when I'm in unfamiliar territory. I don't know, sometimes I wonder, like, when I was younger, would I have made fewer mistakes? But the truth is, like, I was just as dumb when I was younger too. I don't think it's an age thing. I think there are age things, but um yeah, I don't know, man. All right, so num exponent 10. That's so dumb. So dumb. So dumb. All right. And then we have to add 1 here. And then this becomes something completely different. So we don't do this. Okay, so I got 330. Okay, so adding was not the move there. Okay, so now, is this really the way it has to be? Like, I'd like to be able to just easily delete those prints and things. Okay. Looks ship-shape, your test passed me. Okay, so now we have to go in and skip the tests. Okay. I'm not gonna lie, I actually got a little frustrated with this one. With myself. I got frustrated with myself here. But no, I mean, I feel like this... I also do feel like this language is just doesn't seem like it's quite ready for prime time. I hate to be critical, like, it's a good language, but there's just some, most of the other languages on Exorcism have a little bit more polish. All right. Okay, so let's finish up. So here, well, let me leave that. So here we're gonna go value equals number colors. All right. And so now we're gonna say if, all right, and we're just gonna go if value greater than 1 million. Then we're going to do, well, let's do this. Let's say, um, let's just return the whole thing. Append num to string value divide 1 giga ohms. No, excuse me, that's mega ohms. But giga is 1 as well, right? So this one's mega ohms. Okay, right? So then this one can be just value. Okay. All right. Oh yes, this one's just if. All right, there it is. Let's submit. All right, let's do exorcism test. Exorcism submit. And that is going to be resistor color trio R. Yeah. I admit I sort of had a bad time with that. I kept going back and forth and just not understanding the syntax. And I don't know, it just it doesn't seem it I don't know, man. Most of the languages on exorcism are good, production ready. Like even some of the well, let me okay, so let me first of all mark this as complete. So like not all of the languages are like equally like well developed and mature, right? This one is one of those that's somewhat less well developed and mature, right? And that's fine. Like not every language can be Python or whatever, right? Python is very well developed and mature. Rust is very well developed and mature. C++, very well developed and mature, right? Not every language can be equally that, right? So like, I mean, if we look like Zig is not mature. It's pretty well developed. Like, you know, I just used it. Like a lot of people like Zig, and you use it, and it's easy to see why. It's nice. It's nice. It's well thought out. It's nice. Awk has been around for ages, but the thing is, Awk, it kind of shows its age, right? But that being said, it's very well developed and mature, right? It's old school, but very well developed and mature. Arturo, Arturo is cool. Arturo is cool, but I had some troubles with Arturo, similar to what I had with Pirate, where not everything seemed to work, and it's like it's just a matter of not always being sure, like, what am I doing wrong? So in Pirate, I was doing things wrong. I was making mistakes. In Arturo, like, it would run in the playground and not on Exorcism, and there were slightly different versions. I was like, what's going on? I didn't finish any with Rock yet. All right, so let's stop. Like, yeah. And another thing you can look at is like some of these languages have a lot more students, right? So 55,000, that's a ton, right? Compare that to Pirate, which has 131. It's not as popular of a track on Exorcism, right? right? So not all can be equally popular. I think Python probably has the most. I believe Python has over 1 million. Nope. Never mind. Never mind. That would have been crazy though, right? Now this is a ton, over 580,000, but I was like, I think it might be over 1 million. No, I'm crazy. I'm crazy. That might be the most though. Like, I know C Sharp has a very well developed track, and it's an excellent language. One of the best programming languages. Where is C Sharp? Right here. See that? 175 exercises. And it's got over 100,000 students, right? So huge amounts. Which ones have like the most exercises? If we look, so here's, oh, alt number of exercises. And then I think it's, we have to go to the parent node, right? Parent node text content. So 175 is the most. Which one has 165? Elixir, really? Very nice. Very, very nice, with 58 concepts. Oh my goodness. That Elixir track is super well developed. That's amazing. Um, I think Elixir is very popular on this site, and I mean, a lot of people do like it. Like I was saying, I think I do like Erlang, and Elixir is quite close to Erlang, but it does seem like they've introduced like a lot of like features to make it feel a little bit more modern, slick, something like that. I think I get a better impression of the old Erlang than I do of Elixir, but they both seem cool. But like I haven't done much work. Like I've on the only language that I really consider myself to know well is JavaScript. And even there, like I mean, it's not like I've ever been like a professional like front-end developer, right? Like to really know JavaScript, you've got to have worked as a professional React developer at some point, I would say. Because React is, I think, the biggest JavaScript API or the biggest JavaScript framework by far. All right. So another resistor one. There's just one more. It's, oh, it's TypeScript. Oh, interesting. So did I not finish it in TypeScript? Core pack yarn test. Let's give it a shot. It says 7 passed. So do we just need to submit? Let's see what it says. I think I'm not remembering fully, but I think that there was some trouble when I submitted it. Like, I think it didn't work. All right, so that's fine. So we'll mark that. Okay, so that's all the resistors taken care of. What was kindergarten garden again? I've completed it in awk, C, and Perl. Let me look at this for a sec. I'm trying to think, what was the point of this exercise? So we have some letters, C, V, G, or R. Oh, yeah, it was something to do with the name. Like, whatever the student's name is, they get a corresponding plant. I think it has to do with their initial. Not gonna lie, this code is confusing to me. This is hard for me to read. All right, so we start. So we take the student's initial. I don't recall why we multiply it by 2. Yeah, it was kind of a strange exercise. Does my awk code make any more sense? I doubt it. Yeah, so we're doing something weird where the student's initial like determines which plants we choose. All right, let's try it. It's on here 5 times, and I haven't finished any of them. All right, let's give it a shot in Lua. Okay, let's look at our README. Okay, so the children's names are Alice, Bob, Charlie, David, Eve, Fred, Ginny, Harriet, Ileana, Joseph, Kincaid, and Larry. Yeah, really strange. So Alice gets violet radish, radish grass. All right. Okay, so first of all, Lua Char board. Okay, so we can do char and byte. Okay, let's take a look. String byte A. Okay, wonderful. That's all we needed. Great. So, if we go into kindergarten, garden Lua. Okay, so then we're gonna say n equals why is only s here? Let me look at the README again. Huh. So we're supposed to create a table with the names in it, I guess. Okay, so we'll say So S is not the name of the student. S is the garden, right? Local garden equals require. So we're going to return a table. Oh, interesting. Okay, it does seem a bit different from the ones I was looking at earlier. So we are going to return Okay, so let's see. So local names equals Alice, Bob, Charlie, David, Eve, Fred, Harriet. Oops, I skipped one. Ginny, Harriet, Ileana, Joseph, Kincaid, Larry. Okay, so yeah, apparently we do need all those names, I guess. This table here. Okay, so we want to use squiggly brackets. Yeah. Okay, so we'll have those names, and then we're gonna need to go through the input that comes in, right? So do we want to get rid of that new line? Should ignore case for students. Huh. Oh, shoot. Let me see the table again. Is the table going to ignore case? Wait, that's crazy. Case. Table here. Table constructor. So A equals this. Hmm. Should ignore case for students. Okay, so assert same garden.alice. Empty result for student that does not exist. So if we have Katrina, then we should just give back nothing. Ignore case for students. Okay, I'm gonna have to come back to that one. I don't understand that one. Um, okay, so let's say, let me see the table constructor again. Yeah, let's use that. Okay, so then local plants equals, and we're gonna go R radishes, right? R equals radishes. C equals clover. G equals grass. And V equals violets. Okay, so far so good, I suppose. All right, I'm gonna have to hop off for 2 minutes. I'll be right back. All right, all right. Okay, so nope, 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 nope. This one. All right. Okay, so we've got these plants R and so on. So then when we make our table, local garden equals this, I guess. All right. Okay, so then the length of our garden is going to be 1 for the new line plus 4 for each student, basically, right? And we can get the string length. We saw that here in one of these. It was programming in Lua strings. Wait, where is it? Oh. Okay, they just have chapter numbers for titles. String library. Okay, so we are going to have to use string lower at some point. And string length is here somewhere, I believe. String len. Okay. And what about loop? I think we have a for loop, right? Let's see. Control structures, numeric for. I equals 10, 1, minus 1. Okay, so here we'll say for, and we'll say I equals 1. So start at the beginning, right? And then we just want to go through string len of s, and we're going to subtract 1 for the new line, and then divide 4, right? Okay. Then we'll put do, we'll have an end here, and then here, okay, so this goes above here. Okay, so then we'll say garden sub names sub I equals, and then we'll make a list okay. So then we'll say for j equals 1, and we'll go through 4, right? Do. And then at this point, we want to say garden sub names sub I sub j equals string lower s sub j. No. No, 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 no. So this is going to be an expression where it's going to be So we're going to have to calculate it. So let me put in a comment here. What was the Lua comment? Is it with a hash? Oh gosh. Can I think of what it is? Oh yeah, it's this. Okay, so in order to calculate the index, if j is 1, the index is what? I times 2 minus. If j is 2, the index is I times 2. If j is 3, okay, so now here we want to go, so let's see, so what's the index of the new line? The index of the new line is, so in this case, the new line is at index 3, right? The length is 5. So the length should always be an odd number. Let's make that here. The length of S should always be an odd number. Okay. So the index of the new line is what? 1 plus length of S divided by 2, basically. Floor division, right? So when we do a division here, so if I do 5 over 2, what does it say? It says 2.5. So let's see. If we look at here, getting started, numbers, arithmetic operators. Okay, so we have division, relational operator, logical, concatenation, precedence. Okay, so what about floor? Okay, so if we're looking at numbers, no integer type as it does not need it. Okay. So what is this? There is a widespread misconception about floating point arithmetic errors, and some people fear that even a simple increment can go weird with floating point numbers. The fact is that when you use a double to represent an integer, there is no rounding error at all. Oh, okay, so we know that. Okay, so we don't need an integer type, fair enough, but we do want integer division. Mathematical library, let's take a look. All right, floor. Okay, let's take a look. Math floor 2.5. Easy peasy. Okay, so if j is 3, whoops. Oh, I don't know what I just did actually. If j is 3, the index is, let's say, call the index of the new line n plus I times 2 minus 1, right? Yeah, should be. If j is 4, the index is n plus I times 2. Okay, so I'm going to say to calculate the index. All right, so if j equals 1, and let me see the if statement in Lua. Every language, I'm reviewing these things all the time. It's because I'm not remembering well, I guess. All right, so if that, then if j equals 1, then oops. Let me come put this up here. Then garden names sub I, missed one there. I times 2 minus 1. Okay. Do we use an else? Do we use an else if? Okay. Else if j equals 2, then so we can get rid of these. Okay. All right. So this will be 3, this will be 4. So let's set n earlier on, right? Local n equals, and that's going to be math floor, right, of string len s over 2, right? Oh, plus 1. Is plus 1 what I put here? Yeah. Okay, so that's good. And then here, we'll put the minus 1. And here we'll put n plus. Here as well. Plus. Okay. And then what else? So, oh, j is 3. Okay, so here we go. Return function s. Local names. Do we have a Lua format? Lua, yeah, format. Okay. Okay, good. So here's our names. Alice, Bob, Charlie, David, Eve, Fred, Ginny, Harriet, Ileana, Joseph, Kincaid, Larry. Here's our plants, and that I think is okay so far. We'll keep it in mind that that's how we've got them. Then the local garden is starting off with nothing in it. All right, so then I have a little commentary here. Then what about this? So we got the n, math floor, string length s, divide 2, add 1. So if it's 5, then we get a 2.5, we get a 3.5, we floor it to get a 3, and that's where the new line should be. All right, so then we're going to go through here. We're going to divide this by 4. Let me make another commentary in there. The length of S should always be 1 greater than a multiple of 4. Okay, so then we're going to go through that. And then let's see, so 1i for the name of each student in the garden. Run this loop once for each student garden. Okay, so garden name sub I. Okay, so to calculate the index, if j is 1, the index is I times 2 minus 1. Yeah, that's pretty redundant. We can get rid of those. Okay. You know what? I am gonna actually redo that. So what are we looking for here? We're looking for the plant index. So at the end here, we're gonna say garden names sub I sub j equals string lower s plant index. And we're missing something. This should be plants. Okay. Glad I looked through it. All right, so then here, almost all of this is not wanted, right? Plant index equals, right? So how's that look? Better? Okay, yes, better. And then we return the garden at the end. Okay, well, I think that there's a lot of work to do to make this actually correct, but let's see where we're at. So we just run Lua, wait, what does it tell us to run? Busted? Just run busted. Okay, let's see. Was that a lot of output? Okay, interesting. All right, so we ran busted. Oh, got 7 failures. Okay, cool. So with only one student, it says expected objects to be the same. Interesting. Interesting. Okay, so when we run Lua, wait a minute. And I struggle each and every day. Just so dumb. All right. Okay. Um, here it says passed in nil. But here it says passed in something, but it looks like there's nothing there. Okay, so passed in. Okay, so we got empty tables, I think, each time. So the garden was not. So the garden is like this, but we were supposed to see. We were supposed to add some things in there, right? Right. So we're supposed to be adding things in there. So do we see something get printed? No. Oh, wait, yes, actually. So we see tables get printed. Okay. Lua pretty print table. Okay, give us a quick hint here. Oh gosh. Really? Hmm. Okay, well, in the so the busted is showing what we have. Um, Interesting. So a lot of options here. Um, so let's just create, I guess, our own little print table function, just to print garden. So to print garden, so we want to say print garden is going to be a function which when we get the garden, we go and probably just do whatever this person showed. Okay. So we printed Alice, and Alice does have a table. So I mean that's correct. Hmm. But it seems to be showing that we end up passing out tables that have nothing, so that's not cool, right? String concat. Name K. And then plant number is okay. So it doesn't look like we did go through any plants, does it? So not working right, we can see that. So garden name sub I. Then we're supposed to go sub j, which is a number, and then we're supposed to assign a plant. So if we open Lua and we say local garden equals this, okay, and then we say garden sub Alice equals this. Oh. Attempt to index a nil value global garden. Garden equals this. So that might be a hint. That might be a hint as to exactly what's gone wrong. Garden Alice. I think it feels like it feels like I have made an error with regard to scoping, but we'll see. So garden Alice sub 1 equals radish. Okay, so now if we do garden Alice, it shows table, and it shows the radish there. Yeah. Okay. So I've done local garden equals this. All right. I'll be right back. I'm gonna have to go back over there in a second to flush the toilet, but let's see. I did notice um it's funny the way sometimes it's easier to notice things when I'm not in front of the screen and I'm just reviewing it in my mind. I don't know. But I did notice when I was reviewing it in my mind that this is pretty pointless here actually. I think what we really want to do is just not loop through a J at all, and instead it's almost like going back to a little bit of what I had before, but whatever. I times 2 minus 1. I times 2. Ooh, excuse me. N plus I times 2 minus 1. N plus I times 2. Alright, and to get rid of all this, so if I do busted now, 7 errors, should be able to parse a garden with only 1 student. Table index is nil. So, yeah, that doesn't look right. Name Alice, name Alice. I'm not even sure what this red is. Oh, that's output getting mixed up. Um, yeah, so 7 failures. Um, but it didn't have all of these. Oh, wait. Oh, okay, hold on. So here we said 27 table index is nil. Oh, there is no J. What am I doing? Yeah, I'm still only seeing names, right? So that part's not helping. Um, so I don't think we use pairs necessarily. I think we do maybe I pairs. Is that any better? No, it's not any better. Okay, so garden subname sub I. 1, 2, 3, 4. So we go print garden garden. 4 kv in pairs garden do. Name. Okay. Then we're supposed to do I pairs v, but we got nothing. Okay, so it is a table, but it's probably a table with nothing in it, right? Okay, am I going to be able to finish this up? I'm not too sure. I am not too sure. Okay. Well, for one thing, what if we were to just put these things in there, right? So like, just get rid of that, right? Yeah, okay, so that's more direct, right? So garden name sub I, and then we're gonna put all those in there. But I don't think it should be any different. It is more direct, I guess, a more direct way to put it. So when we go to print garden and we pass in garden, printing a garden. So we go printing garden, we show Alice, we show a table. Hmm. Run this loop once for each of the student gardener. For each student gardener. Okay, so we should have plants. Okay, so now let's print these string.lower things. Because I think that's where I'm going wrong, isn't it? Can we index on a string like that? That might not be allowed. Okay, so equals hello. Ah, so we can't. So that's where I've messed up, I guess. We need to use a string library function, probably. Where are my string library functions? Oh no, they're gone! We need to use sub. Okay, that's where we've gone wrong. So we need to use string sub this. And then this twice. Wait a minute. Can we maybe just put it once? No. Do we have another option, maybe? Something... String dot byte? No. Um... Extract a piece of the string. Suffix. If you do not provide a third argument, it defaults to -1. Fair enough, fair enough. String len. String repeat. How about tricks of the trade? It's fine, I just sort of hate it. Well, why would I say it like that? I don't know. Okay, so string sub, string lower. And here we put I times 2 minus 1. Like that. Could be worse. Okay. I think that's it, actually. Okay. So I'm going to now skip printing the garden. Busted. Okay. All right, so 4 successes, 3 failures. And getting close now, close-ish now, maybe to the end. Okay, so should return an empty result for students that are not present. So we got passed in... Oh, okay. So what was returned in that case? So should return an empty result for students that are not present. Huh. Okay. That's... I saw that, but I didn't understand it at first. Okay, let me close this. Okay, so actually we don't want that at all. We want to go... Man. Or I equals 1 through... and then what about the array length? So we discuss an array data structure here. I guess we just have to use I pairs, right? Probably. So I guess that should fix that one. Yeah, okay, 5 successes. Should return an empty result for students that do not exist. Okay, now these last two I actually do not understand. How do we do that? So I think what I just did didn't actually really make much sense. Should return an empty... Yeah, these are really, like, testing my understanding. So I'm returning a table, and a table is what's expected. But for some reason, it's supposed to be a table where when we get... So hold on. Lua programming language, table getters, right? Like, it seems like we're saying that our table should have a getter on it. And when we go to look for something that's not in the table, we need to first convert it to lowercase, and then return whatever it is if it's there, and if it's not, return an empty table instead of nil, right? So let's take a look. Getters and setters. Okay, so they said, oh, wait a minute. We'll store members in an internal table. Really? Oh, this is cool. This is pretty neat. Okay, so it's a meta method, really? Oh my goodness gracious. Is this the way to do it? I'm definitely going to look at somebody else's solution once I'm done here. So this is luausers.org meta methods tutorial, apparently, right? So did they do set meta table here, or what did they do? Well, they used class. I like the idea. So wait a minute. Did they use class here? Interesting. So this guy used something called class, but linked to something about meta tables, or meta methods rather, but meta tables are here. And I prefer the idea of using a meta table, I think, rather than using a class. And then interestingly enough, we can put, and it's even calling it an event handler of all things. That's really interesting. That's really, really cool. So we can use the function set meta table, and then it has this dunder add. Oh, this is really cool. I'm learning something so neat. I actually love this. Okay, so now if we go here, we can see index, which I think was mentioned here. Yeah, right here, double under index. Okay. And so here's all the dunders. And I think the one that I want... Look, perfect. Control prototype inheritance when accessing my table sub key, and the key does not appear in the table, but the meta table has an index property. That's freaking amazing. So, wow. So we started by setting a table, creating a table, then we created a meta table, and then we set the meta table. Okay, let's see what I'm envisioning. That's actually so neat. So let's not do this. So before we return the garden, give it a getter meta table. Okay? So I'm going to say local getter equals, and it's going to be a table. It's going to have a dunder index, and that is going to be set to a function which takes, I guess I'll just call it an I for index. So far, so good, I guess? No, not quite. Okay, so then let's look. So they did function. Okay, so let's close this getter, and then let's end the function. We don't want that. Okay, there we go. Yeah. All right, so now in this function, we'll do, let's say lower I equals string lower I. Okay. And then we'll say if... Oh, wait a minute, wait a minute. Okay, let me look for another hint. So we had a left-hand side and a right-hand side. What about for the index? What did they show here? So they said... Oh, they used self. Are we going to be able to use self? It looks like that's a class thing, so I might need a class thing. Let's look here. Okay, let's look it up. Lua programming language dunder index. So this is under classes. Okay, so let's do it as a class like they did on Stack Overflow. Or maybe not. So they did set metatable A, index equals B. Oh, that seems really cool. I don't understand it well enough to use it just yet. Seems cool as heck. Um, so this is chapter 16, object-oriented programming. But this seems a little different from typical OOP that I'm familiar with from like Java. Maybe it's not as different as I think, but I'm pretty intrigued by the way they're doing this. So we can do set metatable and we can do get metatable. Object-oriented. What is the single method approach? Okay, a table in Lua is an object in more than one sense. Like objects, tables have a state. Like objects, tables have an identity, a selfness that is independent of their values. Tables can have operations. Okay. Okay, so let's crack open our Lua again, and I'm gonna say A equals, and let's just say Alice equals radish. So now if we say A dot Alice sub 1, then we get the radish. Okay. What if we say A dot Bob? We get nothing. All right. So now if we say function A dot double under index, like this, right? Now we say if a sub I equals nil, then return empty table, and no, else return a sub I, maybe, end. So now if we do a Alice sub 1, are we good? Okay. A Bob? No, shoot. Okay, so it's not what I sort of hoped. Let's look again. Control prototype inheritance. When accessing my table subkey and the key does not appear in the table, but the metatable has an index property. Okay, so now having read all that, let's return to this guy because he's giving us a very helpful hint here. You can create a custom setter and getter by overriding the new index and index methods on your class. Note that you'll have to modify Lua sandbox Lua, which is part of Cody, to enable the raw set and raw get methods. Comment out the lines setting them to nil. Okay, so this is using Cody iPad app. But the new index method gets called whenever you attempt to set a property on the table that has not been set before. The index method gets called whenever you attempt to get a property that does not exist in the table. Okay, so that's what I was missing before. If I had just read it, I wouldn't have missed it, obviously. But I didn't have any background to really know where I was. So you can insert custom code for getters and setters by creating a private table in your class and storing your member variables in there. When you attempt to read and write them, you can execute custom code in your new index and index methods. All right. So using the colon there, is that something that I saw here and just... Yeah, okay. So let's go back. Function A. This should have been colon index, I think. And here we'll go string lower. And here we will go string lower. Okay, can we do that? So now A, Alice sub I. No, there is no I. What am I doing? Sub 1, radish. Bob still comes out nil. Function index. Okay, so we want to set the meta table. Add event handler. So wait, what gets passed into the index? Use raw get. No, I don't want raw get. I want index. The function is called passing in the table and the key. That's what I wanted to know. Passing in the table and the key. Amazing. Okay, so we're about to get there. So we're going to say B equals, and it's going to be a table. All right. It has index equals function table I. Okay. So now we say if table string lower I equals nil, then return empty table, else return table string lower I end. Oh, I screwed it up. Oh no. Okay. So now we do set meta table, which is here. Okay, so we're gonna set meta table AB. All right. And now A Alice sub 1 is still radish. A Bob. Oh no! That's pretty nasty. Okay, so let's look again at what I typed and see exactly. Oh, because we tried to get it there. Okay. So I guess what that means is we do have to use the raw get. Use raw get my table key to skip this meta method. Okay, let me think. Do we need the raw get? So here I'm trying to see, hey, does the table have this other key, right? But if it doesn't, then I endlessly loop. So that's horrible. Horrible, horrible. However, we can go ahead and check something else. So we're not going to do that. Let's close. Okay, so Lua, a lot of dumb mistakes, but I mean, whatever. I'm learning. So A equals Alice equals radish. Okay, is that what we did before? Okay. Okay, so now let's go straight to B. So B equals, it's going to be a table like this. We're going to put index equals function table I. Should this be I? I mean, I don't know. Let's call it key. Okay. So if key is equal to string lower key, then, so in this case, we do nothing, right? Well, actually, we return empty table. Return empty table. Okay, great. Else if table sub string dot lower key equals nil, then I don't think this should cause an infinite recursion because now we have this base case where it's already lowercase. Okay. And again, return the empty table. Sure. All right. Else return table string lower key. Yeah? And close table. Okay, so now set meta table AB. All right, so now A, Alice is radish. Alice 2, nil. Alice table. Voila. Okay, so let's go into here. So it's more than I was expecting, I think, but so we're going to say local getter equals, and it's going to be the same thing we did for B. So it's function, it takes a table and a key, all right? And we're going to lower the, so yeah, lower key equals string dot lower key. Great. If key equals lower key, okay, then return empty table, okay. Else if table sub lower key equals nil, right, then return empty table. else return table lower key end. Okay, so then we end the function as well. We end that. Okay, then before returning the garden, we set meta table garden. Yeah? I'm pretty pleased. Wow. Okay, so we run busted, and it says 7 successes. Amazing. All right. That's one of the coolest things I've learned this week, in my opinion. That's actually, to me, pretty neat. All right, so let's then look at this. Oh, let's Lua format first. And then let's look and see if I need to refactor anywhere. Okay, so I have this local print garden. But truth be told, I'm not actually using it. So I will go ahead and get rid of that because it's dead. Bust it again. Okay, cool. We'll format again. All right. Okay, so local names, local plants, local garden. That all seems okay. All right, so then I've got a bit of commentary here. The length of S should always be an odd number. The index of the new line is 1 plus length of S divided by 2 floor division. That's redundant. We don't need to say that. So let's just call this N new line index. And so then that becomes unnecessary. The length of S should always be 1 greater than a multiple of 4. Okay, so then we won't do that. Okay. Local diagram equals string lower S. So now let's not use string lower S anymore. Yeah, just wanted that one place. Whoops. Okay. So local string, let's see here. Let's say char at, and we'll put si, return string sub sii. And so then this becomes, let's see, local, oh, it's function, excuse me. And now let's get rid of the redundant there. It's so noisy, but this is much better. Okay, busted. All right. Okay, so that's better. So yeah, that's simple local char at. Before returning the garden, give it a getter meta table. That was more just a reminder to myself, so that's been done now, so let's get rid of that. Okay. And I'm going to log off here after submitting this and come back after 1 hour. I think yesterday I said I was going to come back after like 2 hours and I never came back or something. Yeah, this time I'll come back after 1 hour. All right, so busted exorcism test. Let's see what it says. Okay. Oh, wait. Before I do log off, I 100% need to look at some other people's solutions. Okay, so that says passed. Good. Community solutions. We're going to look at highest rep user, as I usually do. Ryan++. Let's take a look. Okay. So, local student offsets. Oh, interesting. So we've done it the opposite way, right? So I was looking them up by the number, and here he's looking them up by the name. Not sure, so let's see. Why do we want to look them up by the name? Okay, so we did set meta table. So we return set meta. Oh, that's cool. That's cool. So that's the reason why. Dang. Okay, that's neat. Oh, and they even used a G sub. So plant string. Oh, huh. Interesting. Okay, let's see if I can make sense of it. I missed part of this. So we're going to substitute the first letter, I guess. Oh, cool. I think that seems cool. So they used the Dunder index, same as I did, but they didn't even bother with a table. Interesting, right? Because instead of bothering with a table, we are just going to take the plant string for student, where we pass in a garden, which was passed in as S, and then this was student lowercase. Cool. All right. So then if not student off, so here they did an empty string. Interesting. So did the empty string count the same as the empty object? So this was submitted 9 years ago, so I wonder if the tests have changed since then. Like, I wonder if, because this was returning an empty string, I wonder if that might not pass now. So then they do find. Oh, look at this. %w plus, and then new line, and then the %w plus, so they've made it into these two rows. Okay. And then so yeah, I did the same thing here basically, 2 times student offset students. I kind of did subtract 1, let's see. Oh, but that's because they started with a 0, and mine started by 1, which was like the default. So I just subtracted 1 instead of adding them. That's fine. Okay, and then they take this substring. Oh, row 1 colon sub. Oh, that's pretty neat. So you can do it's a string method with a colon. Hold on, let me see. This is the last thing, and then I'm gonna log off. So a equals hello. So we can go string sub a11, right? Oh no. It's, wait, what was it? String. What was it in my solution? I just did it. String dot sub is what I have. String dot sub. I was thinking back to pirate for a moment. Man, I'm such a mess. Okay, 1. Okay. So if we go a colon sub. Oh, that's better. So then let's see here. String library. Where was that? Tables and objects, standard libraries, string. Standard libraries. Oh wait, where is the reference manual? Programming in Lua. Is this the reference manual? Oh. Oh, okay, I should have been here as well. I've seen enough for now. I'm gonna